Let's learn the continuous time convolution of two signals. Let the signals be u of t multiplied with e raised to minus 3t and u of t minus t, u of t minus 2. So let's take one as x of t and other one as h of t. Now, usually the complex kind of a signal or exponential kind of a signal is considered to be as x of t, and the usual like a step or kind of a simple signal is considered to be as h of t. So let's take e raised to minus 3t into u of t as our x of t. So our x of t is this one. It is a decaying exponential as e to the power minus 3, and it runs from 0 to infinity as e raised to minus 3 is multiplied by u of t. And h of t is a step signal, but as u of t minus 2 is there, it runs from 2 to infinity. Its value is 1 in between 2 to infinity. Now we know that the convolution sum is given by the expression y of t is equal to x of tau h of t minus tau d tau. So we use integration in place of summation because the signal is continuous, and x of tau in place of x of k because k is a k is a discrete variable and tau is a continuous time variable, and h of t minus tau. h of t minus tau is a h of t minus tau is a shifted kind of a signal, shifted version of the signal, d tau. So we go for obtaining what is x of tau and h of t minus tau. So x of tau here, x of tau is this kind of a signal. X of tau is as shown, just a t is replaced with tau, and same with h of t signal. Here also t is replaced with tau, same as h of t signal. And I think there is no problem with these processes as we are already familiar with discrete time signals. Now let's draw h of t minus tau. h of t minus tau, h of t minus tau signal is the time reversed signal of h of tau. So we draw it in a reverse fashion. We draw it in a reverse way. Then it was starting from minus 2 to minus infinity. Its range is from minus infinity to minus 2 because the signal is running from 2 to plus infinity. Now let's take the different values. Now the thing is how this is represented as h of t minus tau. So usually of this h of tau signal we draw h of minus tau only, but we write it as h of t minus tau by considering the value of this t as 0. When this t is taking the positive values, then this signal, whatever is this signal, h of t minus tau signal is going to move on the right side, and when this t is taken to be negative, then h of t minus tau is moving on the left side. So by taking the different values for t, we can move this h of t minus tau signal throughout this region from minus infinity to plus infinity, let's say, and we'll find the result of convolution where all it is 0 and where all it is not 0. So for that, let's consider the case that let's take the left moment when the value of t is negative. Okay, when t is negative, when the value of t is negative, then let's consider that the value of t is equal to minus 2. When I take the value of t as minus 2, then the signal has to shift by 2 units onto the left. So minus 2, another minus 2 will make it as minus 4. So this signal will start at minus 4 and end up at minus infinity. The range of the signal when t is minus 2 is this. So it starts at minus 4 and ends up at minus infinity. Now, as we can see, the signal h of t minus tau is on the left side and x of tau is this one, which is completely on the right side. So there is no multiplication possible between these two signals. Now when we try with the same signal, when we take the value of t as a 0, because this is drawn by considering t as a 0. When we take t as a 0, then the signal will be there at minus 2. So from minus 2 to minus infinity it will be running. But still there will be not overlapping. When we try with, let's say, positive value of t, let's say our t is equal to 1. When t is 1, then this h of t minus tau has to come 1 unit onto the right. When it is coming 1 unit onto the right, it will, like minus 2 plus 1, it would be minus 2 plus 1 is minus 1. So the range of our h of t minus tau signal, or the nature, is it is this way. It is having the startup, means on the right side it will come up till minus 1 and the minus infinity would be its leftmost range. But as we can see, there is no multiplication. When we choose the value of t as minus 2, when we take the value of t as minus 2, when t becomes minus 2, when we take the value of t as plus 2, then when the value of t is taken to be as plus 2, then h of t minus tau signal will be right shifted by 2 units. This signal is right shifted by 2 units. So it will come up till 0. So it will be coming up till 0. So the signal is going to be right shifted and it will come up till 0. Means from 0, at 0 it will be, and from 0 it will be running up to minus infinity. Now in that case, there is an overlap. When overlap only at the 0th instance. When we take t as a 3, then in that case our h of t minus tau, the signal, h of t minus tau signal is going to be right shifted by 3 units, means minus 2 plus 3 is going to be 1. So it comes up till 1. So with the small things is shown, the small diagram of h of t minus tau shows. So it comes to 1 on the right side and ends up to minus infinity. So it is 1 to minus infinity. Then when we take the value of t as 4, when t is 4, then the signal would be coming 4 units onto the right. So the signal, if it jumps 4 units on the right, then from minus 2, if we add plus 4, we'll get plus 2. So it will come up to plus 2. So the signal will be in this way. So this is for t is equal to 3 and for t is equal to 4. And if we take t is equal to 5, it will come up till 3. If we take t is equal to 6, it will come up till 4. Like that, the thing continues. So we can come for the conclusion that as long as t is greater than or equal to 2, there is overlapping. But this overlapping begins from 0 and ends at particular values. If t is 3, the overlapping is happening between 0 and 1, 0 to 1. If t is 3, if t is 4, then it is happening between 0 to 2. So always, whatever the value of t we take, so from that the overlapping region is less by 2. So we can write y of t as long as t is greater than or equal to 2. Y of t is from 0 to t minus 2. X of tau, h of t minus tau, the d tau. when we substitute these x of tau and h of t minus tau from the equations, that is e raised to minus 3t and u of t minus tau, from this we write the equation in this way: e raised to minus 3 tau u of tau u of t minus tau minus 2t tau. So the values of this u of terms is going to be 1, because this equation will take care of those where all they are 1, where all they are 0. So 0 to t minus 2 is our limitation, or is our limits for integration. So overlapping begins at 0 and ends up at t minus 2, because overlapping region is always less by 2 value than the chosen value of t. So just e raised to minus 3 tau remains, and when we solve this, it's going to be this kind of a solution. So the solution of this problem is y of t is equal to 0 for t less than 2, and it is equal to this one. It is 1 minus e to the power minus 3t minus 2 divided by 3 for t greater than or equal to 2. Then we can go for drawing the output waveform. So y of t is given in this way: when t is less than 2, it is a 0. When t is something greater than 2 or equal to 2, it starts existing. So if we substitute the value of t as 2 here in this equation, it becomes e raised to 0. So its value is 0. At a 2, it takes 0 value. When we take t as 3, it is 1 minus 3 minus 2 is 1. So e raised to minus 3 divided by 3. So it is a bit greater than 0. So likewise, by taking different few values, we'll get to know the nature of our signal. And finally, when we take t as infinity, then this output equation will turn as 1 minus anything raised to. Now if infinity it is, then certainly it is e raised to minus infinity. So 1 minus e raised to minus infinity is going to be 1. So 1 divided by 3 would be the value taken by our output at t is equal to infinity. I hope you are getting this problem and try to solve the similar problems, and we can see the next problem as per your request in the next class, next video.